Hello there, Mr. Sutton here, bringing you the Pre-Cal Honors 9-2 Extra Practice Number 2 solutions on infinite intuitive limits. On this problem, to figure out the limit as x approaches a on this graph, we have to look at where we're going from both the left and the right side. As we approach a from the left and the right, it looks like we're heading toward the y value 3 in both cases, so our limit then would be 3. And then for limit as x approaches negative infinity, as we move to the far left, our y values are going infinitely down, so we could write negative infinity or just simply does not exist for that one. For this one, we're trying to figure out the limit as x approaches a on this graph. So as we come from the left, we're going to positive infinity. From the right side, we're also going to positive infinity. So we could write positive infinity or just simply does not exist for that one. Now for this one, as x approaches infinity, as we move to the far right, it looks like we're approaching the y value negative 2. Looks like there's a horizontal asymptote at negative 2 there. So that is our right infinity limit. And now as x approaches negative infinity, as we move to the far left on this graph, we're going up forever, it looks like. So that would be positive infinity or dne for that one. For this graph, as x approaches a, as we consider this from the left, we're going to negative infinity. As we consider this from the right, we're going to positive 2. Since these limits don't match up, we can't really write much of anything other than does not exist for that one. So no matching limits, dne. And now as x approaches infinity, as we move to the far right, looks like we're going up forever. So we could write positive infinity or dne for that one. As x approaches a on the graph here, from the left side and from the right side, it looks like we're heading towards y equals 0. So 0 would be that limit. And then as x approaches infinity here, well, this graph appears to be cyclical. So if this pattern keeps repeating, we're not going to be approaching any specific number, even though we're not going to infinity. So because of that oscillation, we would say that that limit does not exist. On this graph, we're trying to find the limit at negative 2 and also the infinities. As x approaches negative 2 from the left side, we're going to negative infinity. From the right side, we're also approaching negative infinity as we get closer to that vertical asymptote. So for the two-sided limit at negative 2, we could call that negative infinity, or all of these we could call them does not exist, but negative infinity is a little more descriptive. Now as x approaches negative infinity, as we move to the far left on this graph, it looks like our y value is approaching 0. Looks like we have a horizontal asymptote on the x-axis. And then as we move to the far right, we're also approaching the y value 0. So for both of those, we got 0. For this problem, we're taking a look at the limit as x approaches 0. So the left side limit for part A, as we come from the left, it looks like we're approaching the y value 0 as we approach the x value 0. And then from the right side, we're also approaching the y value 0. So the two-sided limit then is going to be whatever these two limits agree on, which happens to be 0. Next, as we approach negative infinity, as we go to the far left, we clearly have a horizontal asymptote at y equals negative 3, and we're approaching that. So negative 3 is going to be the left infinity limit. And as we move to the far right for part E with positive infinity, we're also approaching that same asymptote. So negative 3 again for that limit. On this graph, we're trying to find the limit as x approaches 0 from pretty much every direction. So as we approach 0 from the left side for part A, it looks like from the left side we're going up to positive infinity. From the right side in part B, we are also approaching positive infinity. So for the two-sided limit, we could write positive infinity with the understanding that all of these infinities are really just does not exist with a little bit of direction added into them. Next, as x approaches negative infinity, as we go to the far left, we're approaching the y value negative 4. And as we go to the far right, it looks a little bit different there. This is curving up slightly, and although it's not very steep, it looks like it is going to be going up forever. So this would be a positive infinity or does not exist for that right infinity limit. On this problem, trying to find the limit as x approaches negative 2, from the left side in part A, coming at negative 2 from the left, we're going to positive infinity. As we approach the asymptote at -2 from the right side, we're going down to -infinity. And since these are different infinities, we really have no choice since these limits in no way resemble each other. We have to write dne for this one. These are really all dne, but these first two, we have a dne with a specific direction. For this last one, this is just diverging, does not exist. No real description to give it other than that. Next, for part D, as we go to the far left with -infinity, we're going up forever, so that's +infinity, or also does not exist. As we approach +infinity with x values, as we move to the far right, we could call this either -infinity, because we're going down forever, or dne for that one as well. On this problem, as x approaches -infinity, as we move to the far left, looks like we're going down forever, so that's -infinity or dne for that limit. And as x approaches +infinity, as we move to the far right, looks like we're going along the line y equals -4, so that's going to be our limit to +infinity. For this problem, we're looking at the far left and right behavior. Limit as x approaches -infinity, as we go to the left, we're going up forever, so we can write +infinity. As we move to the far right with x approaching +infinity, this direction, we're going down forever for y values, so that is a -infinity for that limit. And we could call both of these dne, does not exist. These are just a little more descriptive. For this problem, we're trying to find the limit to negative and positive infinity. Now, this function is oscillating, and things aren't getting any closer together. So because we're oscillating, and we're not approaching a single y value as we do that, these are both going to have does not exist as the limits. As we go to the far left and the far right, it's the exact same behavior. So does not exist for A, and oscillating also in the other direction, so does not exist as we go to positive infinity.